Alright, so we go on to 3D shapes. Shapes, nets, and volume. Okay. Number 1, it's from paper 1, 2010, question 18. A cylindrical tank with radius 35 is filled with water. So the keyword cylinder, we already know what we should know, how to calculate a surface area as well as volume for a cylinder. And you fill with water to a depth of 35 or 44 centimeters, sorry. So the question now asks, calculate the area of the base of the tank. So the base, the way it's standing, it's a circle, right? The base, the way it's standing, is a circle. So area of a circle, it's pi r squared. Okay? In this case, we have our pi, we have our r, which is 35 squared. So area of the base, you can use your calculator. Okay, you can give it, round off always to 3 significant figures. If you are not told the level of rounding off, always to 3 significant figures. 3 significant figures. Always. Okay, so in this case, 3 significant figures we count. So to 3 significant figures we count 1, 2, 3. We look at the 4th one. So it's an 8, making the 4 a 5, and so it becomes 3, 8, 5, 0. And its area, so it's centimeters squared. Then we go on to B. Calculate the volume of the tank, of the water in the tank. So B, volume, we know it's base area times height. So our base area is 3850 times our height, it's 44. So our volume will be Okay, or you can first calculate without rounding off. So it's always, we can't use the rounded off answer, so we can just come and say, okay, our pi times 35 squared, then that answer times the height, which is 44. So it's 169,331.84. We do our rounding off to 3 significant figures. So we count 1, 2, 3. We look at the fourth one, making the final answer equal to 169,000. 169,000. Now it's volume, so it's cubic centimeters. Then we go on to part C. Part C says change your answer to part B in liters. In liters. So in liters, that's quite easy. We know that 1 liter equals to 1,000 cubic centimeters. So we simply divide that by 1,000. So it's 169, which is equal to 169 liters. All right, that is it. We go on to the next one, which is number 2. Number 2 is coming from let's continue going down and then we'll come back up. It's paper 3, 2013, question 9. So let's start with A. A says calculate the volume of one cylindrical container. Alright, so we know that it has a diameter of 4. We know volume of a cylinder, it's pi r squared times height. Our pi times our radius is 2 squared times our height is 10. There's nothing fancy about that. Pi times 2 squared times 10. 125.66. Which is equal to 3 significant figures. We count 1, 2, 3. We look at the fourth one, which makes it 126. and its volume, so it's cubic centimeters. All right, we look at B. B says B has got 1. The cylindrical containers are pegged in a box that is a shape of a cuboid. The box is 48, 24 and 10 as shown on the diagram. How many cylindrical containers can be pegged in the box? So we want to know how many can fit lengthwise and how many can fit widthwise. So remember, the lengthwise is 48. We want to fit 4 centimeter thick items. How many can fit, which will be on the lengthwise, it will be 12. How about on the widthwise? It's 24, and we want to fit 4, which means, all right, so 6 across, 6 lengthwise, 6 widthwise, so total will be 12 by 6. Cylinders. $72. Okay. From there, calculate the volume of the box. Okay, that should be easy. Volume of a cuboid. Length times breadth times height. 48 by 24 by 10, which is equal to 48 by 24 by 10. 11,520. And it's cubic. How about part 3 of B? It says find the volume of the empty space in the box filled with the tubes. Okay? Now we subtract the volume of the box, we subtract the volume of the cubes. So our cylinders, remember it's pi times radius squared times height, and there are 72 cylinders. Gives us what? We always don't want to use the rounded off answer. $9,047. So we know it's 11,520 minus 9,047.79. Okay, minus 11,520 gives us 2,472. 2472 centimeters cubed. Always to 3 significant figures. And then we look at part C. Part C says, calculate the surface area of the carton used to make the box. So surface area of a rectangular prism. So we have sides like this, which are 48 by 10. We have 2 of them. We also have the bottom side, which are 48 by 24. The top and bottom, there are 2 of them. And we have the side, which is 24 by 10, and there are 2 of them. Okay, so we are looking at this side and that side, this side and that side, and then this side and that side. So that's completely 6 sides, so we get this total surface area. So 48 by 10 by 2 plus 48 by 24 by 2 plus 24 by 10 by 2. Okay, 960 plus 48 by 24 by 2, 2304 plus 24 times 10 is 240 times 2, it's 480. So at the end of the day, it's plus 960 plus 480, 3744. And remember, it's surface area, so the answer is in centimeters squared, not cubic. That is it. That question had a lot of marks. 2, 4, 6, 8, 10 marks. It was a nice question to have in the exam, All right, number 3. We know it's coming from paper 3 of 2014, question 4. We start with A1. The diagram shows a cross section of KLMNOP, a treasure chest. KMNP is a rectangle, KLMN is a semicircle, O is the midpoint of PN, KP equals to MN equals to 7.4, OM is 9. So they are just describing what we can see on the diagram, which is good. Now part A says find angle MON. 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 Okay, so we have something like that. We have our O, we have our M, and we have like that, and we have like that. We know this is a right angle, we know this is 7.4, we know this is 9. We want this angle. So we have opposite, we have hypotenuse. So from SOHCAHTOA, we know it's sine. Sine theta equals to opposite over hypotenuse. Therefore, our theta will be the inverse of sine of 7.4 over 9. So we comment. So we find shift sine -1 of 7.4 over 9. It's 55.3. With angles, you always round off to 1 decimal place. 1 decimal place. So it's 55.3 degrees. Angles always round off to 1 decimal place. Everything else, you can always round off to 3 significant figures. All right. We'll look for the next question. The next question says, B, calculate the length of ON. ON. Alright, so now we can use Pythagoras, or we can still use SOHCAHTOA, because now we have an angle. It's up to us what we want. It's up to us. So according to Pythagoras, hypotenuse squared equals to opposite squared plus adjacent squared. So we have 9 squared equals to ON plus 7.4 squared. So we take this one there, we get 9 squared minus 7.4 squared equals to ON. Let's look for 9 squared plus 7.4 squared. (26.24) equals to ON squared. Therefore, ON is root of 26.24. So ON is square root of our answer 5.122. Again, 3 significant figures, 1, 2, 3. So it's 5.12. Right. Then we go on to part 3. It says, show that the width of the treasure chest, PN is 10.24. So if we have ON, PN is easy to find. So that is it. You have shown it, and you write that you have shown. And then the last question, which is C, says the chest is 15 centimeters long. Calculate the volume of the treasure chest. Alright, so we need volume of a cylinder plus volume of a, for 2 marks that's a bit, oh okay, because we skipped, we are supposed to go on part B. I was already complaining about the marks because yay. Let's first deal with B. B1 says calculate the area of rectangle KMNP. KMNP. Area KMNP equals to the length that we calculated on top, 10.24, multiplied by the height, which is 7.4. So we have 10.24 times 7.4. Which is to 3 significant figures. We count 1, 2, 3. We look at the second 7. It makes it 75.8. Okay. Next up, part 2. The semicircle. Calculate the area of the semicircle KLM. So semicircle, it's simply pi. So let's first draw. Half of pi r squared, which is half of pi radius, which will be equal to ON, so it's 5.2 squared. Half of radius squared, which is 42.5. And then part 3. Part 3 requires find the area of the cross section of the chest. So now we want to combine the rectangle plus semicircle. A rectangle plus semicircle, which is equal to our rectangle, we got it on top there, 75.8 plus 41.2. So it's 75 75.8 plus 42.5, which is equal to 75.8 plus 42.5 gives us 118.3. Alright, from there we can now calculate the volume if need be. So I think that's C. C says the chest is 15 centimeters long. Calculate the volume. So volume is cross-section area by length. So our cross-section area is 118.3 plus our length is 15, not plus, times, sorry. Times. You don't want to get things wrong when you have done so much hard work and then you fail to complete just because of so it's 1774.5 and it's cubic because it's volume. We move on to the next. Number 4. It says, so that is paper 1, 2014, question 18. It says, calculate the volume of the block. So block, we know it's a rectangular prism, so it's 1.8 by 3 by 1.5. Nothing complicated about that. (1.8) by 3 by 1.5. 8.1. From there, we are told B says a granite tile has a volume of 9 by 10 to the power negative 3. Write 10 to the power negative 3 as a decimal number. So you simply go and use your calculator and make it a decimal, because right now it's in standard form. So it's 9 times 10 to the power negative 3 is 0.009. And then from there they said use your answer in A and the one in part B1 to calculate the number of tiles that can be cut from the granite. So you want to cut things of volume 0.09 from something of volume 8.1. So tiles, you just take your 8.1, you divide by 0.009. That will give you the number of tiles. (8.1) divided by 0.009 gives you 900 tiles. Okay, simple as that. And then we look at the last question in this topic, which is number 5. So it's from paper 1, 2015, question 21. So A says, give the special name for shape A, B, C, D. So the whole shape, what is it called? So the fact that we have 90-degree angles here by DCBA, it means DC and AB are parallel. So 2 parallel sides and 4-sided shape. That's a trapezium. And then part B, calculate the shaded area. Okay, the shaded area is a triangle. And we know our rectangle BCD has got 5 centimeters long and 4 centimeters high, so which means it's not drawn to scale, so don't worry about that. So if this is 4, it means this is 4. So if this total is 8, it means also this is 4. And we know this is 5. So area of a triangle is half base times height, which is equal to half times 5 times 4, which is 10. Five here, 4 here. Don't worry about whether it looks like the 4s are not the same. Not to scale. So that is it for volumes and 3D shapes for the core section. See you in the next one.